Welcome to Chapter 4, Probability Distributions. We're going to start with an introduction to probability density functions. These are continuous distributions. So remember, continuous variables can take on a value, any value within a range. So these are like ratio variables, for example. And they can then take on an infinite number of values. And so it's hard to describe the probability of a specific value because there are infinite ones. So we use a density function, which is kind of like an area. And the probability is based on intervals, not points. If we think about the frequency tables that we did before, even though we were doing discrete numeric variables for those, we were working with cumulative probability so that we could think about the probability of something being less than a certain number or less than or equal to a certain number. And that is definitely the idea of how these operate. So, something like what's the probability of two students doing something? That's a discrete idea. And so we might say instead, what's the probability that no more than two, in other words, less than or equal to two students do that? Instead of the discrete idea, what's the probability of 10 students visiting the reference desk in the library? We could say instead, what's the probability that more than 8 students visit the reference desk? Okay, so you see the slightly different language there. So the questions that we're going to answer are, how likely is it that some range of outcomes will occur? Or, given a likelihood, what range of outcomes do we expect to find? And for this, we're going to use the example of the crazy cat lady, which is an actual action figure. And here are pictures. The one on the left is from Amazon, and the one below is from eBay. And the crazy cat lady comes with 6 cats. And so the question is 6 enough to be crazy? How many cats is normal? And how are we going to define that? So we'll think about that again after we take a look at these distributions, but keep that in mind. How many cats is actually crazy? So how do we get these density functions? Well, you might have seen this before. On the right is a picture of something called Galton's board, and it's a series of pegs, and you drop a marble in the top, and you can see that it's going to sort of hit this middle peg, but then it has to go either to the left or the right, okay? And so let's say it goes to the left, it's going to hit this one, it has to go to the left or the right. And so it's going to do that all the way down. Here's one that's on its way. And interestingly, what ends up happening is that the results form this kind of bell-shaped curve. And you might have seen this before, the bell curve, okay? So that is what we are going to learn to call the normal curve, all right? When we talk about density, then, as probability, we're really talking about area. And it might be a little bit easier to see if you do it in this kind of geometric sense, where we've got the area of a rectangle down here, and then we've got an area of a triangle here. So, you know, base times height for the rectangle, 1/2 base times height for the triangle. You could add those together and get that area, okay? So when we map this onto that curvy function, you can see that what we just had approximates the area there. It's not quite perfect, so we have to be able to calculate area with a curvilinear function instead of a straight line function, but we can definitely do that. We just need some different kinds of terms in it, but that is absolutely the idea. And then we have like this area would be the probability of being from this point down. We're going to define that much better. So we want to ask things like, where do we expect the results to fall? The expected value of this is the mean, which is the midpoint. And by the way, it's a symmetric function. And so the mean should be equal to the median in the standard normal curve. Also, 50% of the curve is below the midpoint and 50% of it is above the midpoint. Most observations fall toward the center, right? And again, if we draw this, right, we can see that most of the things, and I always draw a very bad curve, sorry, it's kind of lopsided, but you get the idea. Most of the things are toward the middle, and there's only a few little things out here in the edges, okay? And again, the word most is not sufficient for statistics. You might think, well, what does most mean? Does it mean 50%? Does it mean 80%? We're going to have a more precise definition. So we need to know how we can map this precisely to probability. And that's what's next.